Okay. Learned a bit about projection matrices. And now... Oh, and I got the mousing over to work. Well, unless you make the screen bigger. I guess I'll have to fix that. I wonder if, yeah, then it just doesn't work. Well, life's hard. First thing, I wanted to make this whole thing turn yellow. So maybe it's just recurse equals true. Maybe. Nope, that didn't work. Oh, I'm only doing the stroke color, so maybe I need to do... Stroke color equals yellow, fill color also equals yellow. Oh, this should be white. Cool. So that's nice. Looks like this gets totally lost if I resize the window. Point at 0. Not totally sure why that would happen. The frame, it's only using the frame X radius. That'd be the same. Could this be changing the mouse point? The center of the mouse point? Blake 4096, what's going on? Okay, so here's what I'm gonna do. I'm gonna print out that point on each frame. So now I can see the location of the mouse. And this is what I'm using to compute whether it's over the button. Now if I maximize this, so right, okay, here, the maximum is like 7.4, 3.9. But if I maximize this and put this in the corner, it's like 35.19. So that's not right. And that would explain why the mouse over doesn't work if I full screen this. So, this mouse point, something about this isn't working, which would make sort of makes sense because I never wrote it, so I don't know what it was designed for. But this mouse point, OpenGL point, this is called from OpenGL renderer window. It's an on mouse move, on mouse motion. It's called here, and this is what's gonna call this one. On mouse motion this. And this is gonna set that point. So the point past here, seen on mouse motion, comes from here, which is this point, which is this, from pixel chords to space chords. And the pixel coordinates, pixel chords to space chords. Actually, I have to see what this does, which I don't know how to do. To space there. So this is taking the pixel width and the pixel height straight from the config dictionary, but this, the config dictionary isn't going to change when I maximize. The config dictionary doesn't even know that I maximize. So how could it? So instead, I think it's possible to read these pixel dimensions from the renderer or something like that. I think. Can I like read from the viewport? Update skipping status. Get pixel shape. Self.frame buffer object.viewport. This reads it from the viewport. So maybe what I want to do is just read from that. So shape here. But I got to print that or something. Did I print self.getPixelShape? And then I'll also print the tuple config at pixel width and this config at pixel height. And I'll look at these two. And I won't print the other thing. And it's gonna crash. Has no attribute frame buffer object. Okay, so I guess this was called before the window was instantiated, which is kind of annoying. I'll just put this in a try. See if that fixes it. So they're both the same here. Aquabeam, what's going on? Okay, so here they're both the same. And actually when I resize, they're still both the same, it looks like. Darn. Oh wait, no they're not. One's updating and the other one isn't. Great. So I want the one that's... So I do want to use get pixel shape. Which raises the question, how can I make sure get pixel shape doesn't crash? Self.frame buffer object. When is this set? Here in its seam? That makes sense. So this should just be like if has atcher or something. I don't know what the frame buffer object is set to originally. Maybe nothing. Maybe I just have to do has atcher self frame buffer object. And that's when I'll do this. And so just return none, something like that. So then I can do if this, I'd want to like set it to something. So like pixel shape equals this. If pixel shape is not none, it's not none. I said if it is none, then I want to like, I'll just return none, I guess. Maybe I should just return 0, 0. What do I normally return? I'll just return 0, 0, 0. And so the rest of this is going to assume that it was not none, and then it can unpack it here, and now it's going to use the pixel shape red from the viewport. So now I can do this, and the mouse over works, and I can maximize the right window. Looks like the mouse over is still working when I resize, so that's great. Good job, self. So what I'll try to do now is, I guess when I click this, I want it to actually pause the camera, but this isn't even really in the place that I want it to be. But, if I move this over, will everything still work? That's convenient. Really, I think I want this smaller. So, put it there, and then I'll scale it. Factor equals half? 0.7 maybe? No, that's weird. Why did it move to a different place? How hard can it be to make it so that you can drag and resize the button mid-scene? I don't think that's something you'd really want to be able to do. It wouldn't be super hard, I don't think. But I'm basing this off of that 3 blue and brown thing. Man, what's it called? Eater dot... So this, resizing the button isn't really something you care about. So I'm trying to take inspiration from that. I think I want to scale this and then translate it. Maybe that would do what I'm expecting. Yeah, now it's in the same place. So here are the points, then I scale them. If I was translating them and then scaling them, why would that make a difference? Weird. So here I'm translating and then scaling. And it's up more. So I'm taking the points, translating those down. It must be scaling around, because it's scaling around the origin. And so those offset points are going to be scaled back toward the origin. So if I scale first, then it's going to scale around the origin, then I'll translate them so it'll be further down. Cool. Okay. So now I want to make it so when you click the button, the camera stops. You'll notice all this data is still updating when I use the camera this way. Oh my gosh, wait. The pause button kind of works too. Only not really. And the way to make this work would be to do ray tracing. But that's for suckers, so I'm not gonna do it. Okay, so when you click, is it like... on click or something? It's all the handlers. On mouse motion, mouse scroll, key press. Wait, where are the ones for... Does key press count as... Oh, whoops. Count as clicking? Is there a handler for clicking? Mouse scroll, mouse motion, key press. There's mouse drag. Let me see. Maybe there isn't one. No way. Find initial position, on mouse drag, on key release. Isn't there like button 1 and button 2? Even that is only in the drag. Okay. This is from Pyglet window. On mouse scroll. The scroll Y parameter gives the number of clicks the wheel moved. Set mouse cursor, on mouse scroll, on mouse enter, on mouse leave, on mouse press, and on mouse release. Okay. So I guess I want to override these. But do I? What I really want to do is to set an updater or some function for this from the source. So set key function def, I'll have on mouse press. I'll just copy all of this. XY button modifiers. And I guess this can only be called from the window. So basically I have something just like this. XY button modifiers, it's just going to call the superclass. XY button modifiers on mouse press. Then under scene, I'll pass the same stuff. XY button. Although this might not even be what you want. This X and Y, it probably wants this in Manim coordinates. It's gonna print the X and the Y to make sure this works. There's no attribute on mouse press. Well, it worked for a little while. Scene.on mouse press. XY button modifiers. Did I not write that? Oh, I didn't save the file. That'll do it. But yeah, this X and Y probably doesn't mean anything to the scene. So I'm just going to do the same conversion that I did before. So point render to pixel coords X of Y. I'll pass the point and then the button and the modifiers. Although I don't know what the button and the modifiers are. here I'm gonna print the point. Print the... I just print all of this. Guess that's not how you do that. Button 1 modifier 0. Right click is button 4. The scroll wheel is button 2. What's button 3? I'm like looking at my mouse trying to find more buttons. Okay, well anyway, the one I care about is button 1, so it should probably be an enum or something. But I don't think Python has enums. What's button dict? I just have 1. This is the right. Just kidding. 2. 2 is the mouse and 4 is the right. Okay, then here I'm gonna put mouse button map at button. I don't know what modifiers is, so I'm not gonna deal with that right now. Why did part of that disappear? Weird. Let's run that again. What's the rest of that button's back? Okay, now it's gonna tell me it's a left click or a right click. Or a mouse click. Great. So what do I want to happen on mouse press? I'm gonna do Python kinda has enums. I didn't know that. Oh, there's like a class. Yeah, okay, maybe I'll do that one day. When I become a good programmer. But for now, haha. Why'd the music get so much quieter? I'm gonna be a bad programmer. Okay, so this is gonna have to... have a list of callbacks. How do we fund development? Oh, currently I think it's impossible. Not just for me, but for everyone in the community, like org. And yeah, like right now it's impossible. Which isn't that great, but our governance structure is so non-existent that there isn't really a way to do it. Like, even if we had money, we wouldn't know what to do with it. Yeah, so right now we're toast. Thinking about Open Collective, I actually don't know. There's some discussion about this in the top secret GitHub channels, but mostly we don't have a clue. Yeah. I'll probably just set up a Patreon one day and steal all the money for myself. Okay, this is just gonna go or funk in Self.mouse press callbacks. But after all, I'm not... But after all, I'm probably never going to get partnered on Twitch or affiliated, because I don't really want to do that. So I got to set something up like that. And I should probably start streaming to Facebook and YouTube, because why wouldn't I? Okay, so I'm going to call func, I'm going to pass it self. No, I won't. I'll just call the func. So with that... Oh, then I need a function for this. Actually, maybe I don't need a function for this. Maybe I can just do self dot... I feel like this one got too loud. Audio issues. Self dot... What did I call it? On mouse callbacks or something? Mouse press callbacks. Dot append. Then I'll write a function. And this won't do anything. Hi. Click button. Perfect. So now I can say if you clicked and the mouse is over the camera frame, then I can print you clicked the button. Add updater mouse over button. Yeah, that's fine. I am so good at programming. Do you see how good at programming I am? This, by the way that this is detecting the mouse movements is not ray tracing. And because it isn't ray tracing... Oh, I think I said this before. This doesn't work. If it was ray tracing, then it would be able to make that work. Great, so now I just have to pause the camera here. So this is the code that rotates the camera. So all I have to change is self.rotation speed, I guess. But that'd be kind of janky. What I want to do is just skip this. Go pause rotation. Is false by default? It's pause camera button only for presenting purposes. Is there a way to show the scene on a web page? No, there's no way to do it on a web page. But I mean, that doesn't mean interactivity is like out the window. There's no reason I can't just like put this code on a GitHub repo and tell people to pull it down. And like, if you want to pull it down, then you could get the interactivity. If you just want to not do that, then you can watch it, I guess. Set up pause rotation. Then I'll return immediately. And this equals not. I've done it. So now you can pause it, move around on your own, or not pause it and see the ambient rotation. That's pretty neat. As you can see the connection to the view matrix there. So now, I think the next thing I'd like to do is show the model matrix and then have a way to pause the triangle rotation. So that way you'd be able to see both these matrices come together. It'd be sort of nice to see the vertices of the triangle, but I guess they wouldn't change. And visualizing the projection matrix from this angle would be really cool if you could see the frustum as like mobjects, but I don't have that kind of confidence in Manim's 3D modeling. Going to Rust make it easier to work online, or is that an entirely different challenge? I think it would make it easier. The thing with that is... Okay. This is what I would be using if I bring it online. WGPU. This runs online, but a lot of the browsers haven't gotten to the point that they support it yet. Let me see if I can find online examples. Okay, so here's the live demos it has. And they don't work on Chrome. At least not on this version of Chrome. Because WebGPU isn't even enabled by default. So I have to go to Firefox Nightly. And I think this will do it. And it didn't work, so... that should show you how much... Oh, it did work. Great. I don't know why this doesn't work. Oh, there we go. Now the compute doesn't do anything. Maybe it's just really slow. It isn't that slow. Like, it works. I mean, it's using your GPU, so... it works as well as you could expect with something using your GPU. I think this doesn't like the fact that it's half screen for some reason. Or not, maybe it's just not working, who knows. But the point is, it is doable. But as of right now, at least, people would have to use like Firefox Nightly or Chrome Canary or something like that. Also, I just don't know Rust, so I'll have to learn some Rust. Yeah. So I guess it is, in principle. I think everything's possible to run this online. I just have to do a lot of overhauling to update that code. Okay, let's make the triangle rotate. If I make the triangle rotate on this, then after that, I'll probably start working from the beginning to get the stuff to where I want to like present it. Then I could do a tutorial stream, and then I can never have to work with OpenGL for teaching ever again. Okay, so here's this mesh. And what I'm gonna do... this is an enormous scene now. Click a button. Rotate triangle. What would be kind of cool is if you could change the rotation around the X, Y, or Z axis. But I think I'm just going to rotate around the X axis. So let's get DT here. And I'll just do mesh, model matrix. So OpenGL.X rotation matrix. And I forgot how you even call this. Pass an X. I'll just put like O.02. No, O.2. And I'm gonna say, yeah, this times. And then I could work more on these APIs so I don't have to rotate things like this. Cenobyte offset. Thanks. That was much easier than I thought it would be. I was expecting this triangle to go haywire. But it is in fact just rotating around the x-axis. Great. Hold on. Yeah, okay. That's working perfectly. So now what I'll do is I want to show the model matrix the same way I'm showing this view matrix. But the thing is, displaying this view matrix was a nightmare. Kind of. But I basically rewrote all this code because it required doing some caching. And if I didn't do this caching, it would be too slow. Okay, let's start with this. I'm gonna have to organize this code more later on. Decimal matrix. So use mesh.model matrix. And then cannot assign member model matrix for type decimal matrix. That's not true. Okay, so I'll do both of those. Then I think I have to add it to the camera frame. So for the projection matrix, I instantiated it here, scaled it, added the updater, which I don't have to do right now. Then I added it to a V group, which I won't do right now. Then this thing, I added to the camera frame, then added to the scene. So self.add and self.camera.camera frame? Where did camera frame even come from? Oh, I built the camera frame manually. The camera frame is a V group. Rotating camera.add. Oh, and then I added this V group to the camera. And since the model matrices are hierarchical, it's using the camera's model matrix to transform things. So I can just do, hopefully, camera frame.add mesh. Oh, not mesh. Great. So I got the model matrix there. And now scaled it here. I basically want to copy what I did with the projection matrix. So I have a view matrix object. I'm just gonna, yeah, scale it there. Make a model matrix object. Add that model matrix. There's no label to add yet. Then I'll add the model matrix object to the camera frame and the scene. Okay, so now it looks the same. The only difference is now I can make a label here. Which I'm also going to completely copy. So I'm going to put model matrix, fill color, I'll make this one red. Model label model matrix is going to be this. So I'm translating it and then scaling it. No, I'm scaling it, then translating it, which is the right order. And then I'll add this to the object. And then see if that appears. And it does. Cool. So everything's working right now, but this code is getting, for one, the scene is just really long. It's like, it's got to be 100 lines or more by now. And it isn't organized. 588 to 940. You expect me to do that? It's 350 lines right now. But okay, I can go here. I want the color of this to be red. And I'm just gonna see how I did that with the projection matrix. So I have it here. None of this colored it blue. Looks like only the updater did that. Which kind of makes sense. Use numbers collections.default dict. I want basically the same code but factored out. Update projection matrix. I gotta change this to update matrix. And then pass the projection matrix. Well, to start, we do that. Okay, so that's doing the same thing. Now I want this to be lambda on something. And on a mobject. Update matrix of the mobject. And then that view matrix, which is this. Okay. I'll pass in this matrix. And then here where I'm using view matrix, I'll just use matrix. Okay, see if that works. And it did. So that means hopefully, if I'm lucky, I can come down to the model matrix. And add in an updater just like this. Model matrix here. Add updater lambda on mob, update matrix mob. I'm gonna choose the mesh.model matrix. And see if that works. And it looks like it did. Okay, so what do we have here? So only the Y and Z entries are changing, which is what I'd expect, because that's what the X rotation matrix looks like. So let me just set a color. Update matrix, blah, blah, blah. I'll just pass in a color here. This will just be color. Hopefully that'll just work, but it might not. Yeah, it looks like I broke something. Oh, yeah, I passed that to the wrong thing. Update matrix of this. Here it should be blue. Great, so that just looks like that just works. At this point, I almost think that ambient rotation should be faster, so that these two match. Maybe a little faster. So we just make this a 3. Actually, that makes it look too rushed. I think I'll actually slow down the triangle. Here? Try making this a 1.5. Maybe even less. 1.2. Okay. Now... Okay, cool. So I'll just position this. I'll also take inspiration from the projection matrix on this too. And just use the same transformation. Model matrix object. Model matrix is OpenGL translation matrix. That should be model. Great, so now they're right on top of each other. For some reason. Wait. I guess that makes sense just because model is a longer word. Okay. And then I'll just make the Y value more negative. Okay, I think that's actually perfect. Maybe both of them could be shifted up a little bit. Or maybe both of them could be moved over here. No, I think that's fine. Okay. Maybe just a tiny... Okay, now I'm bike shedding. I didn't even notice the difference. I'm not gonna do it. I'm gonna stop before I go too far with positioning. Okay, so one thing I want to do is color this model red. I remember I wasn't able to, I wasn't able to index this very neatly. But since I already have this, I guess I just want to increase the start by 1, 2, 3, 4, 5. So this will be 22. And then the length is 5. So maybe I can just do that. Close. Okay. So I think this is doing a decent job of illustrating the fact that these indices... This is actually a little slower now. Or is it? Maybe it's not. I think I just slowed down the ambient, or slowed down the triangle rotation, so I feel like it... Yeah, interacting is fairly smooth for what I'm doing. I wonder if I can click the button from here. And like it'll start. That's interesting. Cool. So now I just have to move these buttons into a better, this button into a more reasonable place. And add a button to pause the triangle. Yeah. So we go to the button, which I just called button. Now where did I translate it? Here I translated y equals -3. I want to do x equals maybe 2 or something? Okay. And I think like right on top of this I want pause model. Yeah. But all of this where it says button, I want this to say camera button. Well, broke something. Camera button's not defined. Oh, it goes way back here. So it gets from here to here. Let's try that. Close. Button is not defined. line 904. Wait, what? Camera button dot model matrix. Button is not defined. Is button used somewhere else here? Oh, maybe it's just because the variable button still exists in the program somewhere. So maybe I just have to rerun that. Nope. Oh, okay, it's a different place. 912. Yeah, I'll say... I'll change this to camera button for now. Even though I'm gonna want the same thing for the other one. Cool. And that still pauses. So that's great. So now I'm gonna copy... Okay. I don't think it would make much sense to copy this whole thing. Pretty much just to change the text. So I'm gonna have to factor this out. Let's call this get button and I'll have like, that's like text in. I guess it would go way back here. View mate. Oh, this is it. Yeah, it goes from. It starts here. Add line 2. Yeah, so pretty much all of this. I'll just say camera button. Store utils that get button. I'll just put all of that there. I won't even have the text argument right now. Self.add camera button text. Do I have to add that separately? I hope I don't. I'm gonna save that. Come back. Bring this back to here. And I'm not gonna add the camera button text. But I will add it to the group. Yeah, and it doesn't appear. That's really annoying. That might be a bug even. But okay. Camera button, pretty much everything here. Wait, add the button, everything up to here. Guess I'll pass it the scene, even though it's kind of weird. That way I can add the text here. Save both of those. Oh, and return it. And call it correctly. Now the border isn't there. We did the get button. So here's the border. I guess I never added that to the scene, so I guess what I have to do is scene the add camera button border. And adding this to the camera frame. Wait, hold on. Maybe I don't have to add those things separately. Well, that's in the wrong place. Scene.add camera button border. I'm doing scene.add camera button text. The camera button border needs to be added to the camera button. Was I not doing that before? Just like this, camera button to add whatever. And it needs update parent equals true. So now I'll see if I can get away with not adding that to the scene. I don't think it's gonna work. And it didn't work. And now if I go back and add that to the scene as well. And this I do think will work. If I'm lucky. Great. Great, so this is the same logic, but more encapsulated. Okay, cool. So I took this camera button model matrix and added it to the camera frame. Okay. So now I should be able to do something really similar for the model matrix. Oh, and I should change these variable names. Yeah, if I'm less lazy. So I'm just gonna copy all of this. Camera frame, come down here. And here all these camera buttons are gonna be model buttons. Wait. So those two, this, and this. Okay. Now, if this was added, it would be right on top of this one, so I would never know. So next what I'm gonna do is say pause model. This one will say pause camera. And that's gonna crash. Okay. Maybe now it won't crash. Well, it didn't crash. But I don't see the model button anywhere. Model button equals this. Model button dot model matrix equals this. I did add it. And I added the text there and the border there. So where'd it go? I'm gonna restart this. No, it's still not there. I half wonder if it's hiding somewhere I don't know about. Oh, I see it. It's like overlaid with the other button. And overlaying I know is known to cause that sort of effect. So when I translate this, instead of y equals -3, let's do a -2. Okay, now both of these are here. I guess it's weird if the camera's up here. The view matrix is up here and the model matrix is on the bottom, but pause model is on the top. Maybe this one should be the -3. And this one should be the -2. Okay, same stuff. I guess I can add the same updater. Oh, this is specifically doing the camera button, so what I'd have to do is lambda on DT, mouse over button, and pass the camera button. And then this will take a button. Do that, do that, do that. This should work the same way. I'm surprised I'm making this many changes without things just exploding. I can add the same line for the model. Great, so now it changes color. This one, click button. I'll call this click camera button. Then I have another one called click model button. Like so. I have to change this pause rotation to pause camera rotation. Yeah. This and this. And I am shocked that that worked. Then wherever... where was I even rotating this? So much stuff. Okay, here's where I'm rotating it. Wait, is that... Did I call the other thing rotation speed? I did. It's only used in 2 places. It should be camera rotation speed. That should be camera rotation speed. Here, I'm gonna copy these. This will be the model. This will be the model. O.12. This is false. This is model rotation speed. And the same thing. Pause model rotation that I return. And this button is going to toggle the model rotation. So that pauses the camera, that pauses the model. And it pauses the matrices too. I sort of feel like these entries are moving a little too slow. It would be nice to show another decimal point, but that would increase the caching by a lot, so can't do that. Cool. So I don't think I'm gonna try to visualize the frustum. That would be too annoying. I mean, maybe I could. Nah, that'd be really annoying. So I think this scene is just about finished. You can see this from every angle that you want. And you can see the shader being used to render the triangle. It would be sort of nice if there was a way to show that the indices of the triangle are staying constant. Though I guess pretty much everything that isn't colored is staying constant. So maybe I could just say that. Cool. Great, I'm mostly done with that scene now. Other than some tidying up and stuff. I still have a fair amount of time to go. Guess I'll see what else I need to work on. Because that's mostly done. Close that stuff. Thanks, Aquabeam. So much stuff went into this from the tech that's always facing the camera, that was annoying, to the view matrix and model matrices that always update, that was annoying. Putting the shader here was annoying. Getting this text to match with the camera was annoying. Making the switch between the two with the spacebar was annoying. The mouse over logic was annoying. The clicking logic was annoying. Yeah, hopefully I won't have to redo much of this again. And now that I have this, I mostly just want to tidy up the rest of the scenes. Let me see. Yeah, it did end up looking super clean. I could do like some tiny polishing. Some small polishes to like, maybe these buttons are a little bit too big. I can make them look more like this. But at that point, who cares? At that point, I should probably make the barycentric interpolation scene interactive. And I think the OpenGL pipeline scene randomly broke. Come on. Not that I really care about that. Well, I do care about it, but oh, maybe it's not broken. Thought it was broken. Nope, that's actually perfect. Pretty fast too. Okay, I guess there's nothing to fix with that either. This is crazy. So much stuff isn't broken. I don't even know what to do. Let me look at the half-screen triangle. It's really straightforward. Maybe I could I could potentially make each of these points variable, like something you could drag on the GUI. But that might be overcomplicating the scene when it's supposed to be really simple. Like, the point of it is that you can basically understand this entire scene just looking at it. Okay. Then from the half-screen triangle, homogeneous coordinates, that's theory. The projection matrix. I had something to teach the projection matrix. This might not totally bridge the gap. What would really bridge the gap here is if I overlaid the Manim grid. And I showed that after applying the projection matrix, this aligns perfectly with Manim's grid. That would be nice. And then maybe some indicator of showing that the projection matrix is being applied. Actually, this would be really good for a slider. Like, really good for a slider. Maybe I'll work on that for a bit. The model visualization is pretty good. Epigram, what's going on? I just, basically finished the bulk of everything I wanted to do for this. So I'm probably gonna end up polishing it or something. I think this does a great job of tying it all together. Maybe, probably in the barycentric interpolation thing. Man, that camera was not ready. Let's start that over from clean. Live synth music. Music I know? Or what do you mean by music? Why did you say you know? What would be really nice here is if you could mouse over this triangle, and that would change the color of like lambda I or something. Wait. Change the color of F. Wait, what is... This is defined so weirdly. F is a color. So you'd move the mouse, it would change the color of F. Just shitty free iPad apps. I'll pass, but thanks. And the F1, F2, F3s could like, yeah, color selection, that would really drive home the way this works. Although I think it's probably equally important to stress that these barycentric coordinates work very similar to Cartesian coordinates. But maybe I'll just say that. This scene isn't enormous. The right and the lambda definition. I'm gonna write this description. Okay, I'm gonna add the updater here, I guess. Is A_I. It's white in the center. Well, it's white everywhere, just like everything's white. Alice and Co. Thanks for the follow. What is AI? Oh, AI is the area of this triangle. What's going on? Okay. Triangle label locations. And that's something I'd probably have to say or something like that. Corner label offsets. Vertex. Where are the lines? Oh, here it is. Vertex fragment lines? So here's what I'm gonna do. Update color or something. Something about this. Oh, wait. Okay, I'm just gonna print mouse point.get center. Technically, the logic I used for interacting with the mouse only works if you add mobjects to the camera frame. And the camera frame is that object that was like fixed to the front of the camera. So it might be a problem with getting the mouse over logic to work, but maybe we can just use something simpler to avoid that entirely. Also, this needs to skip more things. Skip animation preview. Basically, we just want it to go until here. You need like a value tracker? Yeah, probably. What did I do? Construct self.add update color. Oh. I hope value trackers work. Okay, so this is working already. Although, is that 7.05 3.9 in here? Okay, and it works with resizing, so this should be fine. I think. The place where this complexity arises is that technically, in 3D, this mouse over logic requires ray tracing. Which, let me see if I can illustrate that. Yeah, it needs ray tracing to do it right. Because actually, my stuff is so good, I can almost just teach it here. That looks weird with that background. And I can't maximize this. Why? Oh. Okay. So Manim doesn't want you to know it, but the camera's technically doing this. And when you have a scene with that's quote-unquote two-dimensional, it's actually just putting the camera here. So, if I wanted to know when I was moused over something, what I would technically have to do is in 3D space, I'd have the camera like here and an object like here, and I would have the origin of the camera, some point from the mouse, which this is the screen, and like this is the mouse. And I take this point, and I take this point, and I'd cast a ray like this. I'd cast it into 3D space and see if it intersects something. So I'll move this. So there's an object here. But calculate the intersection of this line with this like bounding box. And that's what I would do. Now that's a lot more logic, but that's what I would actually have to do to like do this mousing over. It's like one-to-one comparing the mouse position with the object position is kind of bullshit. It doesn't totally work. And you can see that more here. Okay. But I think I can replace it with something simpler. I want to dedicate an entire day to like ray tracing. To doing real, I guess not totally ray tracing, but kind of. For now, what I think I'd want to do is, assuming I already know the distance from the camera to this plane, which I do, I guess I can just compute which objects it intersects given that assumption. I hope. Or can I? Because what I have right now, I don't even know if these numbers are that useful, to be honest. Why not like bound the space and interpolate the position? I think I know what you mean, like find like this find like the maximum x value, maximum y value, then just interpolate from there. I think actually by default, this is already set up so that this is 1-to-1. I think this is already 1-to-1 because it's 7.1 by 4 in one direction. But I don't know if this space is 7.1 by 4. Okay. Let me just do the following. I'm gonna have to put an updater on a dot. I think that'll work. Update color, DT. And what this is going to do. That's hard. It's pretty difficult at times. Okay, so even this isn't following the mouse 1-to-1. If you put the mouse in the center of the screen, and start with the music playing. If it's at the center of the screen, then it's fine, but as it moves further, this gets more and more off. And that's because it's in this 3D space. I'm super tempted to just ignore it. You guys can just have a cursor that's not at the center. And then come back later. Maybe, okay. But that's closer than I even expected. I thought it was gonna be all over the place. So I'm gonna do this with interpolated dot. Great, so now I took the dot that used to be at the middle. Keyboard or arrow controls. Yeah, that would actually make it probably a little easier. But a mouse would be a lot more visceral. There's like more freedom to it. Okay, so I took that dot. What I want is, I want that dot to stay there until I put the mouse on the screen. So I'll just say if the mouse position isn't the origin. Even though that's not the right way to do it. What I should do is there should be some value, some variable where it only does it when I enter, when the mouse enters. But really it should be only if the mouse point is on top of this triangle. Which means I need a way to tell if a point is inside of a triangle. And I feel like I run into this point inside polygon problem kind of a lot. Thankfully, I always run into it with convex shapes, which makes it a little easier. So let me just do mouse pointing to this. Now, what I want to do is like if, like the point is inside That's the only time I'll update it, if the point is inside the triangle. So pop quiz, how do you tell if a point is inside a triangle? Polygogs. Array casting. There's more ray. The other thing was ray tracing. Although maybe they're pretty similar. It's a winding number with respect to the polygon. If the winding number is non-zero, it's inside the polygon. Sum up the angles subtended by each side of the polygon. I'm gonna do the same thing I usually do for convex shapes, which is usually just taking the cross products and making sure they all have the same sign. Draw a horizontal line to the right of each point. Count the number of times the line intersects and see if it's odd or even. That makes sense. All I have to do intersection with a ray. This is the sort of stuff that I wish was already done. Here's what I'm gonna do. Do I have the vectors for the triangle? These are the corners. There's the triangle corners. I'm gonna say and this is gonna be an array. It's gonna have this at, and I'm gonna want from 0 to 1. Corners at 0. So this one's from 0 to 1. 1 to 2. And then 2 to 0. Gotta be a library. Tracing Copilot. Is it a Python thing? Oh, this. I don't know if AI could come up with like a point inside polygon algorithm. Although it did come up with quite a lot. Holy shit. Can you type in like def next release of Manim and then press tab and it writes the next release of Manim? That's a lot of stuff to autocomplete. But until it comes to Vim, I probably won't use it. It's pretty cool though. What I'm hoping is going to work is this chord is like the exact way that I don't want it to be to make this hard to get out. What I'm gonna try to do is like this is the triangle and define, well, let me do it better than that. have a point here, and then I'll get each of these vectors, and they'll have the same orientation, and I want the cross product of the vector, so like this vector, which I'll call v1, and then this one. These should always have the same sign. So v1 cross u1, and then v2 cross with u2, and then v3 cross with u3. I think these always have the same sign. This is basically saying that as you traverse the triangle, the point is always on the same side. I mean, in this one, they're all into the page, so like negative or whatever. But if I put this outside, then for this one, v3 cross u3 has a different sign. So, I'm just gonna hope that that's correct. I made it up completely on my own. It does not, I know for a fact that it doesn't work on concave shapes. But whatever. Okay, so this is 0 to 1, 1 to 2, 2 to 0. And like, point vectors, I guess I'll call it. Is the point to here, or from here. Then I want to cross all of these. SciPy's convex hull. I didn't know SciPy had a convex hull function. This might have to be like axis equals something. Anyway. We don't use library implementations. Oh, it's not even being called. So you give it points. Hull equals convex hull of points. Hull dot vertices. It looks like this is returning a subset of the points which constitute the convex hull. But that's not what I'm looking for. I'm looking for a Boolean answer. Like, is it inside the convex hull or not? Wait. Includes points, vertices, simplices, neighbors, equations. Okay. So I'm gonna try to cross this. Maybe I'll just return through, I guess. Interpolated dot move to. Okay. So I'll see if this is even 3 answers. I guess it is. Okay, here they're all positive. Here one is... Wait. Oh, the cross product is a vector. So it's gonna go into the screen or out of the screen. But here they're all positive. If I go outside, one of them's negative. One of them's still negative. And it should always be the case that one of them is negative while I'm outside. And on the inside, nope, one of them is negative here. Why? Why? Here it's working. Wait. Here, it's like somewhat close to these edges. It stops working. Like right here. Where's the origin? Well, for each vector, it's doing the difference between them. I really kind of know where he's a student or he's a professor. I just started working on Manim really early on, and that's really it. Well, that's annoying. No, he wasn't a professor ever. Maybe I should know more about what this cross function is doing? Because I don't think that algorithm was actually wrong. No, he wasn't a professor. Array and then another array. The axis of A that defines the vectors, by default the last axis. I think that's right. And by array, this, and this, and you cross X and Y. -3, 6, -3. Yeah, so it's going straight across, I think, is what it's trying to show me. I wonder if it would help to see a visualization of where these vectors are. From point to self.fragment location. Align from point. Not mutually exclusive, I suppose, would depend on your teaching role/level. But he had a PhD. I'm pretty sure he was just an undergrad. Move to point. Shift. Is there a for loop here or something? OpenGL lines are going from the point to a fragment location. Oh, for point and self.triangle corner, so it was right. So it's just these. Oh, but these are shifted. These were shifted. Somewhere. Interpolate, draw the lines. Is it here? Here. All of them were shifted left. So all these points I have to shift left. And I'll just do that here or whatever. This equals 1.8 times the left. Let's see if that works. Okay, normally, so before it's failing around here. Okay, so now I think it's working. And here it's negative on the outsides. When I cross this, it switches sign. Great. So interpolate dot dot move to wherever. Then I'm going to update those lines. Oh, they want to return. How do I do this the fancy way? Numpy dot all. Okay. This is the crosses. Numpy dot all. Crosses. All of the rows. Column 2. It's like greater than 0. Hope that's how that works. UAT lets their grad students take ML courses. Granted, they did a pretty good job. I feel cheated as a student. I mean, at that point, weren't they doing the pandemic anyway? So, like, a lot of the lectures were online and stuff. Okay, this is working now. You want a real professor? Well, there was a generation of MIT students who paid their full tuition, and I taught them algorithms. So I guess that's what the tuition is worth. As a TA. Okay, so what I'm gonna want to do is update the lines. Awesome lectures, but not a whole course. Yeah, you're basically getting free education. Well, I would be teaching if Manim worked better. Although this is getting pretty close to done at this point. What was I doing? Okay. Self.fragment for self.triangle color corners. So I want to do 4. Never thought about pursuing the professor path. No, not at all. Thought anything but I have TA. Nice. It's a crap my professor couldn't be bothered with. Okay, so there's this conflation between what professors are supposed to do, which is research, essentially, to push the field forward. What they're supposed to do and what they do, which is teaching. And these two skills aren't necessarily correlated and oftentimes are not correlated at all. And so ideally there would be different people to do research than there are to teach. And there are, I think there might be teaching professors in some places. Oh, this is the website. Teacher professors. And structure covers everyone else who teaches in you. I guess there's sort of this. I haven't really heard of an instructor role. But I do think that the idea that professors should be good at teaching or lecturing just isn't a valid assumption. I was teaching school, mostly IIRC. Dope. I forgot which one of these I need. Set points by ends and put start and end on do like slightly different things. I think put start and end on will work. Where are those lines? Okay, point and then select that triangle corners at whatever. And say at I. And see how this works. I really like teaching. Wouldn't mind doing exclusively the kind of research I'm interested in. Will never be funded in this climate. Maybe a fun engineering challenge to guide for a CS course. I like teaching infinitely more than I like research and stuff. And so I was really looking for a way to keep doing that after I left college, which is part of how I found Manim. And part of why I wish it was better. So let me move to F, I guess. F here. It's moved here. 0.25 plus right plus up plus that. So I'll put this at move to plus point plus this stuff. Okay. Great, that works. No, I think it'd look better on the left. And like maybe more up. Maybe more up. Cool. Now the location of these A0, A1, A2 isn't always doable, actually. It's possible to just make this triangle so small that there's nowhere to put them. So, wasn't trying to do that. Maybe I'll just put it outside. I'll just put it on the edge in the first place or something like that. Algorithmic information theory stuff, like coding theory, with some TOC, and in my case, thermodynamics physics thrown in. Interesting. I think I'll just move these like right outside. Well, I don't know where to put these. I'll just for now put them at the average of the 3 points, I guess. That's what I'll do for now. I'll get to better polishing later on. Theory of computation. Good times. That was the most difficult part of computer science for me. I label and enumerate triangle labels. A label. Move to. I want to find the average of the two 2 points that don't share its index. Mouse point plus triangle corners at I plus 1 mod 3. I think that'll do it. Like for this 1, I want 0 and 2. For the 0, I want 1 and 2. For the 2, I want 0 and 1. So I think that'll do it. Triangle corners. Self.triangle corners. Plus. And plus 2. Mod 3. I'll take those and divide that by 3. So all of these should have the text shift if they don't already. Mouse point should be mouse point plus text shift. Actually, I could just do line.shift. Like that. That looks pretty fancy. Actually, it doesn't look terrible even when you squeeze it. Doesn't look terrible. Okay, now I'm just gonna wanna get this color, which I hope I can do. Oh wait, I don't want to compute areas of triangles. Wait, hold on. This computation is really annoying. Although I know this is one-to-one with Cartesian coordinates. Now others have to find the area of the triangle, then the areas of all the individual triangles. And I know the fragment colors. I guess it's not terrible. But I'll have to compute the area using the points. Just reuse the function used to generate the gradient. I'm pretty sure I just passed it to OpenGL. Yeah, I did. Although, I know how OpenGL does it. This is what OpenGL does. Okay. You expect me to like align axes and get the cursor coordinates? Yeah, I can. The point is that, like, just given everything, this is the formula for the color. And if I want to compute this, I need to know the lambdas. And if I want to know the lambdas, I have to calculate the triangle areas dynamically. Although, this is getting into the weeds. I know for a fact that these are one-to-one with Cartesian coordinates. Or affine. And if lambda 0, lambda 1 to lambda n are the barycentric coordinates of a point or the barycentric frame, the affine coordinates are lambda 1 to n. So you have an origin and n vectors to form an affine frame. Then like S equals, well then I have to get those lengths. Wait, I already have these vectors. It's these triangle vectors. I can just compute it again, I guess. Oh, I'm doing a more general one this time. Meta array. P1 minus P0, comma, P2 minus P1, P0 minus P2. Why is this crying? Expected 2 positional arguments. Oh, like this. So we can do this, then I need S, then ABC. I can say A equals numpy dot linealg dot norm. Well, I can just get the norm of all of them, right? Just say norms. Norm of vectors, right? And I think that goes row-wise. Okay, the axis equals 0. So this is norming along the 0 axis, that's down. Otherwise it does it along the 1 axis, that's across. The default axis is none, okay. Blah, blah, blah. If axis is none, then either a vector norm when x is 1D or a matrix norm when x is 2D. What is a matrix norm? Anyway, I think that by default, no, I should check it. Um, 1 0 0 1 2 0 0. Norm R, and I won't put a backspace there. Well, that's not what I expected. So I guess I do have to put an axis. Okay, so I want to do this along the 1 axis. Okay, so that's the A, B, and C. Then S is the sum of the norms divided by 2 times a half. Hope that's a real function. I'm going to do S times S minus A times S minus B. Oh, but there is no A and B and C. I guess I could do a like... I could subtract the norms from a vector of S's. But like, who's got that kind of time? I'm just gonna... Norms at 0. Norms at 1. Norms at 2. I think that'll be fine. Hopefully. Now let me test this. gonna pass this origin up and right. And this should be 1/2 base times height, so this should just be half. And it is half. Because I am really good at programming. Okay. So now I can do triangle areas. Maybe I could just call this, yeah, triangle areas. Oh, I don't even know what points to pass, man. Well, I guess it's these three. For I a label and enumerate triangle labels. The location equals... Okay. Triangle points equals... Oh, this should be a list. And this is numpy.sum of this divided by 3. Okay, so this should do the exact same thing. But it doesn't. Because that would be too easy. Oh, this doesn't have commas. It still doesn't. Darn. Oh, this needs to be numpy.array. Now, I still don't know. I guess not. But this sum should be axis equals 0. Oh, guess you... Oh, not this. This sum. Perfect. When in doubt, try more things. Okay. So now I have the points. I'll put triangle areas here. At the end of this, I'll do triangle areas dot append. And I'll do star. Triangle points. Although I don't know if you can unpack numpy arrays like that. But we're gonna find out. It looks right. One of them is going to 0. Here they're kind of equal. Here one of them is going to 0 again. Here one is going to 0. The sum is like 17.7. Yeah, this seems right. Let me put that back. What was I even doing? Okay, so I have the triangle areas. So now I can find the lambdas. And this is the sum. Nice sum. Triangle areas. The lambdas. It's area divided by total. For area and triangle areas. If you put value trackers on the areas, you can update them too in real time. Value trackers on the areas. What do you mean by putting value trackers on the areas? In the formula. Oh. Yeah. I'm just bad with value trackers, to be honest. They're like abstracted updaters, pretty much. Although that would work. This is not... Yeah, that's true. The thing about value trackers... I don't know if you can control their ordering. So like if I did... Wasn't trying to do that. If I did like... No, I don't even know how value trackers work. There might be an easy method. Yeah. A big problem that I'm running into, that I'm starting to run into with updaters, is that you can't control their order. So if you have an updater, if you have some sequence of updaters that's like, why did that happen? Like this happens, then after this happens, this, oh my gosh. This happens here, and then this happens, that's reliant on this. But if you just do like 2.add update or whatever, and then 3.add update or whatever, well, I guess it would actually work in this case. But if you had something like this, something like this, then you don't have a way to enforce this structure. Like, I guess what you would have to do is add them in this order, 1, 2, 3, 4. But if it happens to be the case that you had to like 2.add updater, and then later on you do, oh no, it'd be the other way around, 3, and then you do 2.add. Yeah. It'd probably be, yeah, but that's what it is. My tablet's literally right there as well. Okay. Now we got the lambdas. So now I'm gonna say the fragment color is a convolution. Can I average colors in Manim? It's just R, G, and B. I don't even know if I can. It's hex. Yeah, that's true. So I should be able to just... should I be able to do this? FFOOOO. Colors. I'll put that there. That there. It's gonna be some of... How do I do this? I want to zip them. Why isn't it a convolution function in Manim or in Python? lambda times color. Or L times color, lamb times color, lamb times call, zip, lambda's colors. And the actual color is the sum of that. I'm not sure this is something I can interpret just by looking at it. Yeah, not at all. But okay. Then maybe... I feel like this isn't gonna work. It should like... color... Yeah, because it isn't in hex anymore. I feel like what I'd have to do... R is right, G is up, and B is out. So now these are vectors. Wait, hold on. Yeah, it's RG and then B. So these are the colors. Then I can do... Okay, this I think works. Lambda times the color. And then it's summing those. That should be numpy.sum. Now let me try printing this. It's gonna be a vector. Well, that's not what I expected. Because I thought it would be a vector. Oh, this isn't even a numpy array. I'm gonna do a numpy array of this. Then would it be just this? I think this is pointwise by default. So I'm gonna see what that does. Okay, here it's mostly blue. Here it's mostly red. And here it's mostly green. Okay. So then I want to sum this along the 0 axis. Okay, this looks like it's working. So now, I can say the fragment color RGB equals tuple of fragment color vec, and then I'm gonna take the dot and set it to that color. Oh. I have to say fill color there. Guess I can do HSL equals this color. Then you do HSL equals HS. Then like a little bit more than L. But like I don't think this can go over 1. Oh, maybe it can. But now it just looks... Wait, now it just looks white. Was I looking for saturation or something? Yeah, I'll try that. Yeah, that's too high. Okay, last try before I give up. I'm gonna go min of double and 1. Still, oh, is it too dark? You can tell it isn't the exact color that the background is because it's too dark still. Yeah, oh well. I have to look more into how to do that computation. Pretty much everything up to here. Everything up to here is just theory. After that, there's some coding change to get right. But okay. I'm going to raid someone. Let's see, what do we got here? So tutorial complete? Yeah, pretty much. I still have to do some writing and probably like polishing some stuff. But all of the main stuff on it is done, yeah. I just have to prepare what I'm gonna say and stuff. Who is this? Okay, maybe this person.
The first time I tried to quit vaping, I told myself...
Oh, I remember who that is. This person just started. Oh wait, this person's partnered. This person's enormous. He's not even gonna know who I am. Okay. We'll... Oh, this person.
The first time I tried to quit vaping, I told myself that it was like a mountain.
This person does security.
And once I got to the other side, it would be clear.
If only I could see what he actually is doing without the ads. But I can't, so... Dope. Say hi, and I'll see you guys in the next stream.